Additive manufacturing or 3D printing started with the idea of rapid prototyping in 80s. And when engineers wanted to find some quick solution for the ideas that they had, and they wanted to quickly see what they're thinking about and show it to the other people and say, okay, this is what we want and let's build this thing. It improved since 1980s with different techniques. That the first one was called like stereolithography technology, and it was developed, new technologies started, and people could make new techniques and also go through making new materials, using new materials for 3D printing. The concept is simple. If we can make a model, 3D model from a component, from a material, from an object, then we feed this model to a computer, and computer will slice this model to very small, tiny layer of assemblies, and our production equipment will deposit or develop or build those tiny layers individually within the time and builds our material. This is simple. There are lots of advantages with this technique, and these advantages are including that it is very rapid. We are cutting all those other steps that we use in traditional fabrication techniques here. We just make a model and we build. We will reduce the waste material in this technique because we exactly build what we want, and the other extra parts and materials that is used for other technologies are being eliminated. One important, very important aspect of an advantage of additive manufacturing is complexity of the components is not an issue here anymore. As we say, sky is the limit, because you can build anything you want with any internal complexity and kind of geometry from the materials you want. And the important thing here is that the complexity won't change the price. However, somehow it can be considered a disadvantage, because in mass production of the materials, when you are in high quantity of production, the price and cost of the production goes down. But in additive manufacturing, although the complexity won't increase the cost and price, but mass production also won't reduce the cost. It can be considered as one disadvantage. Another important thing in 3D printing is that it is actually what we call as reverse engineering. You see a part, if you have equipment to to build model for this, either your ingenuity to make the model or your expertise, or if you have a 3D scanner and you can scan through this thing and make a model, you can build it. It is exactly what we call it reverse engineering. And this is technology that has been found many applications during especially a couple of past years, and industries are very attracted to this technology. Currently, plastics and polymer-based materials are the most used materials for 3D printing. However, the new advanced 3D printers are developed for metals and ceramic materials. Depending on the application and depending on the requirements, almost all type of materials now these days can be printed by additive manufacturing technology, but those plastic materials are commercialized. The technology for producing them is kind of available and cheaper, but still it is expensive for production of metals and ceramics. There are different ways we can classify additive manufacturing or 3D printing technologies. However, ASTM has its own methods of classification of them based on the technologies that is being used and also the materials. For example, techniques like material extrusions or material jetting or material bindings or photopolymerizations are being used for plastic and polymer materials. Some of them also can be used for ceramic materials. For example, photopolymerization, when it's in two modes, one of them called direct light projection and laser stereolithography. They can be used for production of ceramic materials by additive manufacturing. Material extrusion is what is very commercially available and used these days, as we know, as the FDM technique. Also, technologies such as direct energy deposition or powder bed fusion, these are being used for metals. Laser is being used in these technologies. However, how we introduce material in front of laser is the way that we can build metallic materials using those techniques. I am going to talk about the advanced application of additive manufacturing. These days, aerospace industry, they are investing a lot on research in the area of the additive manufacturing. For example, GE has spent more than $1 billion just on additive manufacturing recently, and their next generation of jet engine, CFM LEAP, which is going to be available in 2020, is I know that is almost like more than 80% of that engine is built by additive manufacturing. Different nozzles, different blades in airplanes or aircrafts are being made by additive manufacturing. In automotive industry, additive manufacturing has been used for a long time, and even these days they are using it to build different components. But one of the interesting use of 3D printing in automotive industry is when a company comes up with a new idea and new design for new like line of production or new cars. What they do, they build a prototype of the entire car from, for example, plastic materials by 3D printing of them. Now you can think about that some of those parts are too big, and the 3D printers that are capable of producing them must be very advanced. Anyways, this is a very interesting use of additive manufacturing in automotive industries. In oil and gas industries, different drill bits, different components that can be and are being produced using additive manufacturing. Additive manufacturing and 3D printing are being used in biomedical and dental applications. Just one example that I can tell you that recently happened for an eagle which lost its beak, and they modeled that beak and they made it from some material which has close properties to the actual eagle's body tissues, and they inserted that, and then it was very well and good looking. Consumers and machineries, everyday tools and things that are being used in houses architecture, mapping, civil structures. These are other users of the 3D printing products and additive manufacturing process components. Also fashion industry. Now you can see dresses and shows that the models are walking with the 3D printed dresses. One of very interesting application of 3D printing is in the food industries. And many restaurants in some countries now, they are 3D printing their food. And in fact, the first time when I started working in this area, like a couple of years ago, and first kind of seminars and presentation that I had, I told like as a joke that someday you go to the restaurant and a server will ask you, how would you like your burger be printed? Well done, rare, medium rare, and it's kind of happening some places, and it's not something that, it's not a joke anymore. As I mentioned before, using 3D printing for producing metals and ceramics is a little bit expensive. Not a little bit, I'm sorry, it's very expensive these days because equipments are expensive. Now, one of the things and challenges for future is making equipment and machineries that are producing metals and ceramic by additive manufacturing technology cheaper and more available, and this would be one of the challenges of future in this, and one of the areas of growth for in additive manufacturing.